Students, today we will practice the questions related to the frequencies and wave equation. Okay, the given question related to the frequency is that, for example, such questions can also come in exam. Ahmad plays a note on a guitar. The note has a frequency of 512 hertz, and how many times a second does the string vibrate? So the given data in the question is that frequency is given, which is 512 hertz, okay, and time is given a second. It means 1 second. So in 1 second 512 is the frequency. So how many times? So there is number of vibration is being asked. Okay, so we know that the formula of frequency is equal to number of vibration divided by t, as n is number of vibration. Okay, number of vibrations divided by second. So frequency here, the value of frequency is 512 is equal to n divided by 1 second. So here number of vibration would become 1 second multiplied by 512 is equal to 512 times. There is another question that a wave having a wavelength of 20 centimeter. Okay, this is the wavelength, about vibrates about 3 times per second. Find its frequency and speed of wave in meter per second. So here the given data is that wavelength, we denote wavelength by lambda. Here it is 20 centimeter. And number of vibration, which is also denoted as n, is equal to 3 times. And what is the time of second? Per second, 1 second. Okay, so frequency is equal to, we know that number of vibration divided by time, it would be equal to 3 over 1 second. So frequency would become 3 hertz. Is that clear? This is the one part. Another part, this is the speed of wave. Okay, so this is part A of the question. Okay, part B of the question is that you have to find the speed. Now, as we calculate in part A, that frequency was 3 hertz. Okay, and what is the wavelength? Wavelength is 20 centimeter. Okay, so we know that speed, which is also denoted by V, is equal to frequency multiplied by wavelength. So here frequency is 3 times multiplied by wavelength, which is 20 centimeter. Okay, 20 centimeter. This is that you have to calculate speed in meter per second, and the wavelength is given 10 centimeter. So you have to convert centimeter into meter. For this purpose, you have to divide the centimeter over 100. Is that clear? Now we will calculate. Okay, 21225. So here 3 multiplied by 1, 3 over 5. Now if you divide 3 over 5, what will happen? We will get 0.6 meter per second. So this is the speed of the wave. Is that clear? So calculate the frequency of a sound which has a wavelength of 0.5 meter and travels at a speed of 340 meter per second. So in the given data, what is the information given to us? This is wavelength. Okay, wavelength is given 0.5 meter and a speed, which is noted by V, the speed is given as 340 meter per second. What is required? We have to find the frequency. So we know that if the formula, as it is being asked, we know that the formula of speed is equal to frequency multiplied by wavelength. So frequency would be equal to speed divided by wavelength. So here speed is 340 meter per second and wavelength is 0.5 meter. So the unit meter will cut with each other, and so we can also write this as 340 divided by 5 multiplied by 10. Okay, 5 1 5 5 2. So here the frequency would be frequency 340 multiplied by 2, 200, 428 and 326, 680 hertz. Is that clear? Such questions that if the speed of sound wave is 340 meter per second, what is the wavelength of a note of frequency? 340 hertz and 170 hertz. Okay, now you have to find the frequency in both the cases. So what will we do? In part A we have to solve like this. Okay, solution in part A, they required what is the requirement? Wavelength. Okay, and in part A frequency is 340 hertz. Okay, and then speed of both the waves, these are the 340 meter per second. So we know that the formula of speed is equal to frequency multiplied by wavelength. So wavelength would be equal to speed divided by frequency. So wavelength is equal to speed. Here it is given 340 meter per second divided by 340 hertz. So the wavelength would be 1 meter. Okay, this is the first answer of first part. Okay, now the second part says that in the second part frequency, here frequency is 170 hertz. Okay, and we know that as the speed is the same in both cases, 340 meter per second. So we will just put the values over here of part B. So here the speed is 340 and the frequency is 170. So 0 get cancelled with 0, and as a result, let me 17 to 34. So here 2, 17 1 2. So wavelength would become equal to 2 meter. So the second wave, this wave has a greater wavelength, that is 2 meter, and this wave has a smaller wavelength, that is 1 meter. And so you can see that the wave which having 1 meter wavelength, its frequency is quite larger, higher frequency. So frequency is quite higher, and the wavelength, the wave that having greater wavelength, its frequency is lesser as compared to the first one. So wavelength and frequency, they have inverse relation. A very important question, that the speed of light is 3 to 10 raised to power 8 meter per second, and this speed of light is constant, okay, in air. So you have to calculate the wavelength of violet light. Wavelength of violet light having frequency 7.5 into 10 raised to power 14 hertz. And then we calculate part B, calculate the wavelength of red light. Wavelength of red light of this amount of frequency. So now coming towards part A, okay, solution of part A. Okay, now here the speed of light is 3 into 10 raised to power 8 meter per second, and the frequency, given frequency is 7.5 into 10 raised to power 14 hertz. Okay, so what we are going to find? We are going to find the wavelength, which is equal to speed over frequency. Is that clear? As already we have done this. So wavelength, we will put just the value of speed, that is 3 into 10 raised to power 8 meter per second divided by frequency. that is 7.5 into 10 raised to power 14 hertz. Okay, so this is how I can also write, okay, that 3 into 10 raised to power 8 divided by 75 into 10 raised to power 13. Okay, why? Because I remove the decimal point on that side. Is that clear? So it will get minus. So after this we can write okay, we will cancel the values 313, 326, 3515. So 1 over 25 26 3515, okay, into 10 raised to power 8 minus 13. So 1 divided by 25, it will come 0.0 25 4 100, so 0.025 0.04 into 10 raised to power 8 minus 5. Okay, yes, 1 2 0.04 into 10 raised to power minus 5. So I can also write in significant form. Instead of that, 4 into 10 raised to power here 2 zeros minus 2 into 10 raised to power minus 5. So together it will give us the value 4 into 10 raised to power minus 7 meter. Okay, so this is the wavelength of violet light. In the part B of this question says that frequency here is given, that is 4.3 into 10 raised to power 14, and we speed as usual 3 into 10 raised to power 8 meter per second. So again we have to find the wavelength. So how can we find the wavelength? We know that speed is equal to frequency into wavelength. So wavelength would become speed divided by frequency. So we will put the values. Okay, we'll put the values. Wavelength would be 3 into 10 raised to power 8 meter per second divided by frequency of red light, that is 4.3 into 10 raised to power 14 hertz. Okay, so 4.3. okay, so it would become, I can also write 3 into 10 raised to power 8 divided by 43 into 10 raised to power 13. Okay, so wavelength would become 3 divided by 43. If 3 is divided by 43, it would become 4. Let's divide this value. 43 divided by 3. Divided by, multiplied by, suppose 9 3s are 27, so 36. So something like it would become 0.078 into 10 raised to power something like this, or the value would become nearer to it, into 10 raised to power 8 minus 7. So lambda would become, or the wavelength would become 0.078 into 10 raised to power minus 14, 10 raised to power minus 6. So I can also write 7.8 into 10 raised to power 2 here, 6 minus 2 minus 8. So this is the wavelength of red light. Okay, wavelength of red light. Is that clear? Here is another question that a wave passes a particular point every 1/10 of a second. So here the vibrations, okay, is equal to 1/10, and time is given 1 second. Okay, what is the frequency? You have to find the frequency. Simply we'll put the value formula of frequency, which is a number of vibrations divided by second. Okay, second time. So frequency is equal to 1/10 divided by 1 second. So what will happen? Which is equal to 1/10. So frequency would become, I think, 0.5 hertz. Is that clear? Very important question, that a heart rate is timed at 72 beats a minute. What's the frequency of heart rate? So here the heartbeat is the vibrations. Okay, so here number of vibrations, which are the heartbeat. Okay, these are 72. And what is the time? It is a minute, 1 minute. This is a minute. Okay, a minute means here it is 1 minute, and inside 1 minute there are how many seconds? It is equal to 60 seconds. So keep in mind that when we are calculating frequency, we have to convert whatever the given time into second. If it is hour, we have to convert this into second. If it is minute, then we have to convert them into second as well. So here 60 second, the second time. Okay, so we know that frequency is equal to number of vibration divided by time in second. Okay, always keep in mind. So number of vibrations, these are 72 divided by 60 seconds. Okay, now let's do the cancelling of the numbers. 2 divided 30, and if we divide it by 2, 3, 6, 34. Okay, 3, 6, 12 to 4 to 6, 12, sorry, to 6, 12. 6 to 6, 12. Okay, here 2 divided by 2, 15. If it is divided by 2, it will become 1, 2, 18. Now by 3, 5, 8, 6. So here it is, frequency is equal to 6/5. This divided by 6 divided by 5. So 1 point, approximately it will become 1.12. I think this is approximately 1.2 hertz. Is that clear? So here, dear students, another question was a little bit different from the wave equation. Okay, so here the given data is speed of sound is given. Okay, the given data in the question is speed is given 330 meter per second. This is speed of sound wave. Okay, and time is given, that is 3 seconds. Okay, so what you need to do, how far does that sound travel in air? So distance, you have to find distance. Okay, distance, you have to find the distance. So keep in mind one thing, that the wave equation that we have calculated, that is the V is equal to frequency multiplied by lambda. This equation is basically used for electromagnetic waves. Okay, or for those waves, okay, for those waves whose wavelength is very small, very small, very small, whose wavelength is very small, we use this type of wave equation. Okay, this is called wave equation. Okay, so having very less wavelength and very high frequency. Okay, but there are some waves whose wavelength is quite long. Okay, they have very lengthy wavelength. Their wavelength is very large. Okay, they have very large wavelength. So for this type of waves, we simply used the formula of speed, the simple general formula of speed, that velocity is divided by distance over time, that you have also studied in your previous classes. Okay, why I'm saying this? Because there are some waves whose wavelength is up to several kilometers, like radio waves. Okay, like radio waves. Okay, their wavelengths is up to many kilometers. Okay, for this type of waves whose wavelength is very large, we use simply this formula. Okay, now coming towards the solution of this question, that we will simply use this relation, that we know that speed is equal to distance over time. So here the speed is given, time is given, we need to find the distance. So we know that distance, we will find the distance from this equation, that here distance is equal to speed into time, because we will transfer value of time on that side. So distance is equal to 330 meter per second multiplied by 3 seconds. Okay, seconds will cancel each other, so the distance would become 300, 339 and 339, 990 meter. Okay, so this is the actually distance of the sound covered in 3 seconds. So in 3 seconds, 990 meter of the sound wave will transfer. Is that clear? Here another question, the last question, that radio station transmits on a frequency of 100 megahertz, and 1 megahertz is equal to 10 raised to power 6 hertz. The speed of radio waves is 3 into 10 raised to power 8 meter per second. So what is the wavelength? Okay, so again you have to find the wavelength. Okay, and frequency is given, that is 100 megahertz. Okay, 100 megahertz means that 1 megahertz equal to 10 raised to power 6. So 100, I can also write in scientific notation, that 100 multiplied by 10 raised to power 6 hertz. Is that clear? Or simply we can write that F is equal to 1 into 10 raised to power 678 into 8 hertz. Is that clear? So speed is given. Speed is equal to 3 into 10 raised to power 8 meter per second. So you simply need to find the wavelength, and we know that wavelength is equal to speed over frequency. So we just put the values. Speed is equal to 3 into 10 raised to power 8, and frequency is equal to 1 into 10 raised to power 8 hertz and meter per second. Okay, so wavelength would become, this got cancelled, so wavelength would become 3 meter. So one wavelength of the sound is, as you can see over here, 3 meter. So sound wave wavelength of the sound waves is quite bigger, 3 meter. Is that clear? So this is part A of the question. Now part B of the question says that there is how long does the transmission take to travel 60 kilometer? How long does the transmission take? So you need to find the time, that how much time is required to take the transmission up to 60 kilometer. Okay, so let me rub the board. Part B of the question says that how long does the transmission take to travel 60 kilometer. So how long does the transmission take to travel 60 kilometer? So for this purpose, definitely distance is given. Okay, distance is equal to 60 kilometer. 60 kilometer, we need to convert them into meters. So 60 multiplied by 10 raised to power 3 meter, because 1 kilometer is equal to 1000 meter. So I can also write in this form. I can also write this, that 6 into 10 raised to power 4 meter. Okay, so here time is required. Okay, so the simple, we know that speed of light, okay, we know that the general formula of speed is equal to distance over time. So speed, time would be equal to distance divided by speed. Okay, so what will we do? We will put the value of distance. Time is equal to distance. Distance is 6 into 10 raised to power 4, and velocity of light, this sound wave, is 3 into 10 raised to power 8 meter per second. Is that clear? So we will simply cancel the values. 313, 326. Okay, then time is equal to 2 into 10 raised to power 4 minus 8. So is equal to 2 into 10 raised to power minus 4 second. So this is the time of the transmission. So that 60 kilometer requires that amount of seconds, 0.0002 seconds. Okay, this amount of, so its speed is very high speed, and that's why it requires so much less time in order to cover the 60 kilometer distance.